Okay, this is lesson 44, Algebra 2. In the previous lesson, we talked about sine, cosine, and tangent. It's important to remember how you set them up. Remember a little phrase. Oscar had a hold on Arthur, meaning opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So let's look at our solving right triangles. So we said the sine of 37 degrees, doesn't matter what of 37 degrees, you put in our calculator in 0.601815. And it doesn't matter what size of triangle, that angle is always going to give you that. Doesn't matter the size. You're always going to get, when you sine of 37 degrees, that amount. So let's use our Pythagorean, not our Pythagorean, let's use our sine and cosine to find sides of triangles. So we know H, Y, 9.5, and 24 degrees. They want us to find B and Y here. Well, we know this is 24 degrees. We know the sum of the angles of a triangle have to equal to 180. So this is 90 plus 24, so this must be 66 degrees. Yes? Now, we want to find H and Y. If we had Y or H, we could use the Pythagorean theorem to find the missing side. But we are missing 2, so Pythagorean theorem is not going to help us here. So what we can do, remember we said, if we say sine of 24 degrees, we're saying opposite side divided by the hypotenuse. Oops. Okay? Which would be Y over H. So the sine of 24 degrees equals that. Well, that doesn't really help us because we have 2 unknowns. And in order to solve this, we have to have 1 unknown. So, and could we pick 66 degrees and do the same thing? Yes. Doesn't matter. We can just decide which one we're going to do. Then we're going to use our calculator. But first, we're going to kind of estimate what we think H and Y is. My drawing doesn't show. If you look at the drawing in the book, in example 44.1, Y is much shorter. So we're going to estimate Y to be between 3 and 6. Then we're going to estimate H to be between 10 and 14. Okay? We're just estimating before we go and do that. So let's just decide, are we going to pick 24 degrees or 66 degrees? Let's pick 24. Then we have to go and find the sine and cosine of each one. So sine of 24, we said, is going to be Y over H. Remember, opposite over hypotenuse. Cosine of 24 is going to be adjacent, 9.5 over H. And tangent is going to be opposite over adjacent. Here we have 2 unknowns. So again, it doesn't help us, but we have 1 unknown here and 1 unknown here. Now we can simply go to our calculator and hit cosine of 24 degrees. Cosine of 24 degrees is going to be 0.91. And tangent of 24 degrees is going to be 0.45. We don't need sine because we can't use that one. So can't we simply replace 0.91 with that and equal to 9.5 over H, and then we could solve for H. Just like we could replace this with tangent of 24, so 0.45 equals Y over 9.5. And then we simply solve for H and Y algebraically. Here you would multiply by H and divide by 0.91. When you do these, you're going to get, for H, you're going to get H is approximately 10.44. And Y is approximately 4.28 when you do it this way. Okay, so now it agrees with our estimates that H is between 10 and 14 and Y is between 3 and 6. So it agrees with our estimate, so we did it right. But let's look at this a different way. We round it. When we did sine of 20, cosine of of 24 and tangent of 24, we round it to 2 decimal places, which changes our answers slightly. So let's just basically, if we're solving for h here, we're saying h times cosine of 24 degrees equals 9.5. Divide by cosine of 24 degrees is what you get for h, right? So if you take your calculator and do 9.5, divide it by 24 degrees, or hit 24 and then cosine and then the equal button, you're going to get h is 10.40. Isn't that a little bit off from what we got? It is, because of our rounding. And if you do the same thing over here, and you solve for y, and you type in your calculator tangent of 24 times 9.5, you're going to get 4.23, which is even more off than what we got. Okay, so it's just approximate forms. You're going to estimate, and your answer is going to be off a little bit. It just depends on how you round and when you round. Okay, let's look at example 44.2. Find the missing parts of the triangle. All right. Go ahead and erase this over here so I can draw the triangle on this side. So here's your triangle. Okay. And you've got B degrees. We have X, M, 35, 14. Well, we can find B because we know this and this has to equal to 90 because this is a right triangle. So you're going to get 55 degrees for B. Now, we can either take sine, cosine, tangent of 35 degrees or 55 degrees. It doesn't matter. I like working with smaller numbers, so I'm going to find them. So I'm going to do sine of 35 degrees on the calculator, and I get 0.57. Tangent equals of 35 degrees is going to give me 0.7, and then cosine of 35 is going to give me, and I simply did these, I put them in my calculator. Okay, so now we want to say sine of 35 degrees equals what? Opposite over hypotenuse. Cosine is going to equal to adjacent over hypotenuse. And tangent is going to equal to opposite over adjacent. This won't work because I have two unknowns. So I can't use this one, so I have to use these two. So I'm going to say 0.57 equals x over 14. 0.82 equals m over 14. And you simply solve for x and m. Okay? So when you solve, you get x is approximately 7.98 and m is 11.48. Now we see, and we should have estimated first. We should have said, well, m is smaller than 14, so m is going to be between 8 and 12. X is a little bit shorter, so we're going to say x is between 6 and 10. Did we get that? Yeah, so we did pretty good. We were supposed to do that first, sorry. So we see that x is equal to 14 times sine of 35 degrees, right? Now what 0.57 is. So if you put that in your calculator, it's 14 times sine of 35 degrees. You're going to get 8.03. You see how it's off slightly? Because we rounded up here. So it might be better that you do it this way instead of rounding. I'm good with either way, so if we take a test, I'm going to give you credit whichever way you use, but I need to make sure that I see consistency in your rounding. And if we do m is equal to the cosine of 35 degrees times 14. And here we're going to get 11.47. That one was actually closer to our original one. So that is it on doing that. So let's do one more. the next example, because now they don't give you the angles, they just give you the sides. So we're given this triangle over here. And it's a right triangle. This is A degrees, B degrees, x 7, 6. Well, we can use the Pythagorean theorem to find x, right? 6 squared plus x squared equals 7 squared. When you finally do it, you end up getting x equals the square root of 13. So this is the square root of 13. So now we've got to find angle A and angle B. So let's start with A. Let's just use A. So we said sine of A equals x over 7. Cosine of A equals 6 over 7. And tangent of A is going to give us x over 6. Well, these two have unknowns. This one, the only unknown is the angle, which we can find. So remember, if we divide 6 by 7, we're going to get 0.8571. So the cosine of A is equal to 0.8571. Now remember we talked about the inverse in a previous lesson. So to find this angle, we type in 0.8571 and hit inverse of cosine, and when we do that, we get 31.007481, which is approximately 31.01 degrees. So A is equal to 31.01 degrees. Now, if you didn't round, and if you divided this in your calculator and then went straight to inverse of cosine, you actually get a 31 if you round to 2 decimal places. So it's just on your rounding. Because they round it first, it rounds up. So if A is that, what is B? You subtract this from 90 degrees, which is 58.99 degrees. And it's as simple as that. That's actually really easy. If you know the sides, you can find the angles by finding its inverse. Okay? That's it. That's all you need. Alrighty? So you do your practice problems. There's only 2. We'll see you in class.